Okay, this is a short video of using CAD data in ArcGIS. This video does go along with our assignment for this week called Using CAD Data in ArcGIS, AutoCAD ArcGIS Integration. It also will go over some of the concepts from our PowerPoint discussion from this week. It will not step through every step of the assignment, but it'll give you a good overview of the assignment and working with CAD data in general. So as part of this project, this assignment, and every project you do in GIS, you typically create a directory structure to work from. In this case, I told you to create a folder called CAD, and inside of that CAD folder, create a few other folders. For me, I created one called Mod2 CAD. And inside that folder, I know that I have some CAD data for this assignment, and I know I'm going to save a map document, so I have a map document folder, as well as I've got a shapefile I'm going to work with. Usually I'd have multiple map documents and shapefiles, but this is a good start for a directory structure for this particular project. So I have already downloaded the data and extracted the data from Moodle. I'm going to need to create a file geodatabase because eventually I'm going to get this CAD data translated into my geodatabase. Usually I create my geodatabases at the project level directory. I don't create a folder just to put a geodatabase in. I usually put it in the project level folder here. It comes in edit mode, which I can just start typing to rename. This is we're going to be working with a elementary school and from West Buncombe, and so I'll just call this geodatabase West Buncombe. So when you get some CAD data, the very first thing you typically do is you have to explore the CAD data to gain a better understanding of how it's structured and what kind of information is in it. So that's what we'll do first here, and in our catalog we can look at this CAD data set and see there's many feature classes in it. The feature classes you will always see are annotation, polygon, polyline, and multi-patch. Within these feature classes, there'll be many features of your GIS that you would like to incorporate into your GIS. Occasionally you see other feature classes broken out, and sometimes these are valuable to you and sometimes they're not. If the CAD technician worked based on the Esri mapping specification for CAD, you may see more feature classes broken out into a way that they're already thematic in nature, like your GIS data is. In this case, we see some that might be like highway, and if we preview this, well, you'd think that would be a highway, but I don't really see much there. And in the table, I'm looking at the geography and I don't see any, and if I look at the table, well, there's a couple of lines, but they say they're highways, but I don't see them anywhere, and so it doesn't look like that's going to be something I can really use. Here's a circle feature class. I'm not sure exactly what that's made of. It's got some points. It looks like it came off the ML1 layer. I'm not sure what layer is ML1. So that doesn't look too useful to me either. Maybe guardrails. These are some points from a guardrail, it looks like, but I don't see the points with the rest of my data. So the feature class that I always look at and explore very closely is the polyline feature class. So it's this feature class here. CAD technicians often put their geometries, line, and even polygons onto a polyline feature class, and you can see that this feature class looks like it's got a lot of GIS related information. So this one feature class looks like it has a building on it, this green, or maybe multiple buildings. It looks like I see contour lines. These red and green lines look like contour lines. This may be a road up this way, maybe some other kind of landscaping feature. This looks like parcel boundaries to me. So the point is that this one polyline feature class in the CAD data set actually has what would be in a GIS environment on many different layers. In a GIS environment, we would have a buildings feature class, and a contours feature class, and a parcels feature class. So this is pretty common in the CAD world. These things are all thrown onto one feature class, and what we have to do is filter out based on the original CAD layer and then convert them to feature classes in our geodatabase. So how do we do that? Well, we see the geographies here, and we can look at the table as well, and you'll notice that there's a layer field. And so by identifying lines, you can determine what layer they were on. So this, which is obviously a building, is actually on the ML3 layer. So let's look at this one. That one's harder to select because it has some overlapping, but that building right there on the ML3 layer. So that tells me that the buildings are on a CAD layer called ML3. It's not incredibly descriptive. It'd be nice if that layer was called building, but it's not, and it's often not. So we have to explore the data to figure it out. How about this line here? What layer is that on? It's on a layer called C Topo Minor. So that's a little bit more descriptive. It's a topo line, it's a contour line, and these are the minor topo lines, and the green ones in between are the major ones, or the index contours. So you'll see when you look at the attributes for CAD data, as mentioned in our PowerPoint discussion, the attributes are more commonly display types of attributes, whether a layer is on or off, locked, maybe the color, maybe the line type and the line width. So there's lots of these display characteristics, and less often you'll see user characteristics like the elevation of that line, although in this case you do have the elevation. An important attribute, though, that you usually find in these layers is a layer attribute that tells you you can select based on the original CAD layer that the information was on. So that's already starting to give us some good information. Let's go on and look back at this polyline feature class and the geography of it. You know, I think I want to pull the buildings out of this layer, maybe the contour lines, and maybe the property boundary. So if I look at this, the property boundary looks like it's on ML4. ML4 seem to be the property boundaries or the tax boundaries. So that's good, important information to know, what layer things are on. The other thing you want to consider when you first start looking at CAD is what kind of coordinates are stored with this CAD data. And if you look down here in the bottom right of the screen, you'll see the numbers they're pretty low. Usually a real-world coordinate system like state plane coordinates or UTM coordinates, or latitude and longitude for that matter, will have larger numbers. Latitude and longitude not so much. But state plane and UTM will have large numbers. State plane coordinate system is in the 900,000 and 600,000 kind of range. UTM is in the 300,000, 3 million range in the X and Y. So what that tells me is this CAD drawing was drawn in local coordinates, or not really based on a real coordinate system. They just arbitrarily started drawing around 5,000, 2,500, and they designed their drawing based on that. So we're going to need to, in order to overlay this with other real-world data, we're going to need to georeference this file. So before we georeference it, let's look at what we're going to georeference it in relationship to. So georeference allows us to translate or assign real-world coordinates to a CAD file or an image that does not have real-world coordinates. So if we look at this parcel layer that I provided, it looks a lot like those parcel lines from the CAD data. So it's the same area. I I pulled out the parcels just that you need and provided them. So you can see here, this data, if you look in the bottom right, has coordinates. They're in the 900,000, 700,000 range. And if I look at the properties of this layer is in NAD 83 state plane. It's in state plane feet. So if we georeference our CAD data to match this parcel data, that means our CAD data is going to be in state plane feet too. So before we even move on, the first thing I'll do is I'll just tell it that this data is going to eventually end up to be in state plane feet. It has an unknown coordinate system, and again, since I know I'm going to translate it, georeference it to match the parcels, I know it's going to be in the same thing as the parcels. Currently it's unknown. Since I just looked at that coordinate system, it shows it in my favorites. If you don't see it in the favorites there, you could pick it out of the projected coordinate systems. You'd have to go down to state plane and find the correct one. But it's easier if you know the layer you're going to translate or georeference based on, just to import from that layer. So in this case, I'm going to go import from that shapefile, and it takes on that coordinate system. So I have now defined the coordinate system for what this data will be eventually. Okay, now that's a nice step to go on and do now. We could do that later, but that's a nice step to go on and take care of now. Now notice that does not give my data state plane coordinates. If you see the coordinates down in the bottom right, they're still unknown. This data still needs to be georeferenced, but once it is georeferenced, what that defined projection will allow it to do is to project on the fly to match data that's in a different coordinate system than what this is in. Okay, so we've done a good bit of work here already, just kind of inventorying our data. So now let's load our data into ArcMap. Now I could drag this whole drawing file over to ArcMap and it would load all of these feature classes. But really I just want the polyline feature class, because that's what we're going to pull a little bit of data out of and convert it to thematic layers in our geo database. So I'm going to add that to this map document, and if I go up here to my CAD folder, I will add that polyline feature class, and there it is. Now if you didn't define your coordinate system, you would get an error there saying it's not defined. I did define it, so it thinks it's in state plane feet, even though you see the coordinates down in the bottom right are much lower than state plane feet. So there's my CAD data, and I'm going to go in and add my parcel data that I'm going to georeference this based on as well. All right, now before we do anything else, I want to set up my map document appropriately, and this is something you should also do in pretty much every map document you ever create. Under the File dropdown, you can get to Map Document Properties, and under Map Document Properties, it's nice to set our default geodatabase to the database or the geodatabase for our project. Now, there is this default geodatabase that's named Default Geodatabase that gets installed in your Users Documents folder under ArcGIS when you install the software. And so if you're not careful when you're working in ArcMap, things get dumped to this default geodatabase. It has to have some kind of default operation for data that gets created. Where does that data go? It goes to this default geodatabase unless you tell it that you want a different geodatabase to be your default geodatabase. Now another thing we like to do is store relative paths. That will help this data become more transportable. If you moved from one computer to another and the drive letter changes on your flash drive, this setting will stop it from losing the location of the data that the map document references. So make sure and set those two for every map document you make. Let's go on and save our map document too. And I'm going to put it right here in my MXD folder. this is wbunk.mxd. You can call it whatever you want that is descriptive and makes sense to you. Okay, so something we can do with CAD data in ArcMap is we can change the display properties. So if we go to the properties of our CAD data, something I wanted to point out here is that you have a drawing layers tab, and because one workflow for people who work with CAD data in ArcGIS is that they simply overlay the CAD data with their GIS data and use it as a layer, then you can turn on and off different layers within the CAD file. So we could come in here and turn everything off, disable all, and say just turn on the buildings and the contour lines, or the buildings, the parcels, and the contour lines. So that's turned on a little bit more, but you can change how much information is shown on your CAD file this way. So remember, you can work with CAD data directly in ArcMap without converting it to a geodatabase feature class. However, you can't edit it. It's just a layer you can use as a read-only file. So that's fine for now. We'll look at it just for this. Now, we've got our parcels loaded, but where in the world are the parcels? Well, remember, these are showing at the coordinates you see in the bottom right. And if I zoom to the full extent of all of the data that's loaded in this data frame, our parcel data is actually right up here. And if you look in the coordinates in the bottom right, those are state plane coordinates. And all the way down here near the origin, that shows the CAD data right there. So they're in different places because they have different coordinates. So I'm going to zoom back in to the parcel data, and I'm going to georeference this to match the parcel data. Now, the georeferencing toolbar I have turned on. You can turn it on by going to Customize, Toolbars, and Georeferencing. You can also right-click in the gray area and turn on and off toolbars. Notice that the layer to be georeferenced is the CAD drawing in this map document. You can georeference CAD data and images. Make sure, if you're working with this georeferencing toolbar, if you had some images loaded in this map as well, that they were not the ones being focused here in this drop down, because that's what would be georeferenced when you started the georeferencing process, which is what we will do now. So I know that I want this data, this CAD data, to be up here in this area where these real world coordinates are. So essentially, the geoprocessing process, you choose a location on the CAD data that's in non-real world coordinates, and then you pick the real world location represented in the parcel data to assign a real world coordinate to it. This does not store the real world coordinates with the CAD data. This information will eventually be stored in a world file that tells the CAD data how to display. So, zoomed into the real world coordinates under the georeferencing drop down, we can fit to display the CAD data shown in our drop down above on the georeferencing toolbar. And it just essentially throws that CAD data up close to my current display. And this came really close, actually. I actually can I could use some tools to make it move closer. I could shift it over a little bit so it gets a little closer, and I could also scale it a little bit to make it fit more. Okay, now it's close enough that I can add control points without making it much closer. So I'm going to zoom in a little bit and add the control points. Remember that when you georeference CAD data, it uses a 2-point similarity transformation. What that does is it takes 2 points and it allows you to move the CAD data, rotate the CAD data, and scale the CAD data. If you took GIS 111 at AB Tech, you saw georeferencing when we georeferenced a scanned map. Georeferencing an image allows you to enter in more than 2 points, and it allows you to actually rubber sheet and stretch a raster file to better match an area. CAD data you cannot do that with. So, 2-point similarity transformation. It's best to pick 2 points around the outside of your CAD data. So, this corner is that corner, and this corner is that corner, and this corner is that corner. So I'm going to grab my control points. It's very important. You start with the CAD data first, click one time, and then click another time, and that added 1 control point. From there, I'll click this one to there, and there's 2 points. Using those 2 points from the georeferencing dropdown, I will now auto adjust, and you see it moves it pretty darn close. Now, it's not perfect. The CAD data is actually probably more accurate than the parcel data in the GIS. Once CAD data from surveys is converted to parcel data in a GIS, because each surveyor surveys based on their own local coordinates sometimes, the GIS data has to be stretched and matched so that all the parcels fit together in a quilt work or fabric of parcels. So this is pretty close, and we're going to accept it for what it is. To save the world file of our georeferencing, you must update georeferencing. So what that does is that saves a world file that stores the from coordinates and the to coordinates, just 2 pairs of coordinates, and that world file is used to display the CAD data in its real world coordinates. Again, the actual CAD data is read-only and is not updated. This world file just saves with the drawing file here. So when I update georeferencing, you can see it's going to save a world file. It's going to put it in my CAD folder, and notice it's not here now, but updating georeferencing saves that world file to the same folder as my CAD data and is named the same thing with a different extension. So what ArcMap does now is if you go to load this drawing file into ArcMap, it automatically sees that there's a world file in that folder, and so it knows that it needs to use the 2-point similarity transformation stored in that file to display this in real world coordinates. The projection file allows it to project on the fly to match a different coordinate system if it needs to. So I can open this world file in a text editor and see that it's just the from coordinates, the to coordinates, the from coordinates, the to coordinates. 2 sets of coordinates. The georeferencing toolbar has not been around forever. We used to build these files by hand, and it was really easy to do. The georeferencing toolbar makes it even easier. Okay, so we've georeferenced our CAD file. So now, a really common workflow after you georeference a CAD file is that you select out information based on that layer field, and then you convert it to a feature class in your geodatabase. So I'm going to select my attributes, and I'm going to select for layer equals ML3. And if I click OK, you can see it selected these buildings. Now there are a couple of building lines or something around the boundaries of the parcel that might be buildings on another parcel, or I'm not sure what those are, but we're going to just accept that they're there for now. So I've got them selected, and so I can right click this layer, this CAD layer, and go to data and export data. And what I'm going to do is I'm going to export the selected features. It's going to take on the layer source, the coordinate system from the layer. Since I defined this, it'll take on state plane, and it's got the state plane coordinates. The output feature class I want to build, I'm going to put it in my geodatabase feature class, and I'm going to call it building. And click OK, save, and then OK. And It's going to ask if I want it to add it to the map. Sure. And if we clear our selection and turn off the CAD data, you'll see I have a buildings feature class in my geodatabase now. So the second one we're going to do, we're going to select by attributes, and we're going to select for the parcel that after exploring the data, I learned that it was in the ML4 layer, and you can see it's selected there. Now I'll export that, data, export data. Never let it call your file export output your feature class. That's not descriptive enough. Always name it. This is parcel boundary, no spaces. It doesn't allow spaces. And also notice that these exports are automatically going to West Buncombe. That's because we set it as our default geodatabase. Makes things much easier. Okay. Yep. So that's a real common workflow. And so what I've done now is I've got a parcel boundary geodatabase feature class, a building feature class. They're in real world state plane coordinates, and they came from CAD data. So CAD data is a rich source of GIS data, and it's easier to often convert it from CAD than to create it from scratch. Now again, that's a real common workflow. But I also want to make mention of some geoprocessing CAD tools, or some CAD geoprocessing tools. So this can be done outside of ArcMap, just using geoprocessing tools. So there's one called feature class to feature class, and if we search for it, we'll find it a little bit easier. That's the search button there. And so let's search for feature class to feature class. And feature class to feature class, here it is. This converts. We can open it and look and see what it does. Alright, so if you look at the help, converts a shapefile coverage feature class or geodatabase feature class to a shapefile geodatabase, shapefile or geodatabase feature class. It actually also works for CAD data. So, what I can do is I can take this CAD layer, okay, and drag it over here. And if I tell it to dump it to my geodatabase, I could dump all of the lines from this into my output feature class. But notice I can put in an expression. So using the feature class to feature class tool, I could I'm going to create building 2. I could create it telling it only to pull out layer equals ML3. So what this tool does is the same thing that doing select by attributes and then right-clicking and exporting did. It's a little bit cleaner and more streamlined. However, what I often find is that I'm spending my time in ArcMap exploring the CAD data. And so as I explore it, it's easy just to do a select by attributes and export the data. I usually don't know enough about the data just to come in here and do this without first exploring it. So essentially, in my workflow, it's easier just to select it and export it while I'm exploring it. But let's just see this work. And you see it chugging away down here. It's processing. And there's my, well, it failed for some reason. This failed last time I did it, yesterday. Let's just try that again and see. Oh, okay, I had some things selected I shouldn't. I think I know what happened there. Let's turn off that, turn off that. Okay. Zoom to this layer. Okay. So let's just try that again. I'm going to search for it again, and it remembers it here. And so the input features are that West Buncombe again. My output location is my geodatabase. And now I'll make another file, building 3, because I just made building 2. And let's tell it to search for layer equals ML3. I'm not sure why that failed the first time, but it failed the first time yesterday. I think looks like it'll probably work this time. Again, I'm selecting my CAD data. I'm outputting to my geodatabase. I'm giving it a good name, and I'm selecting out just the buildings. So here we go. You see it running down here. And that time it did work. You see the little checkbox, feature class to feature class, and you can see if I make this maybe a thicker red line, you'll see the buildings really stand out. All right, there they are. Okay, so feature class to feature class is a CAD geoprocessing tool that you may find useful. There's another tool. There's another tool that I want to point out to you called CAD Dataset to Geodatabase, and you can search for this as well. In the exercise, you're going to use it. Now, this is a conversion tool that'll take the entire CAD dataset, and it will create individual feature classes in your geodatabase, and it will put them inside of a feature dataset. So again, let's just drag our CAD data. That wouldn't let me do that. I'll just add it this way. It should have let me drag it. I'm not sure what happened there. Alright, so I'm going to put my CAD file in here, my CAD dataset. It's going to output to my West Buncombe geodatabase. And it's going to create this West Buncombe CAD feature dataset. And so inside of my geodatabase, we have feature classes and we have feature datasets. Remember, feature classes can be standalone, but you can also organize feature classes into a feature dataset. So what this tool does is it creates a feature dataset, and then it takes all of the feature classes from that CAD data and it dumps it into the feature dataset. So it puts all of the CAD data in. We will just keep the defaults for reference scale, and our spatial reference is correct there as well. And so before we run it, I want to look here at our geodatabase and remind you of what's in it. Now, notice I'm selecting my geodatabase and there's nothing in it here. I've exported stuff to that geodatabase, but I haven't refreshed ArcCatalog since I have. ArcCatalog often doesn't refresh. You can refresh it by going to View and Refresh, or pressing F5, which is what I usually do. And so I've got these 4 standalone feature classes. The buildings layer I got by selecting by attribute and exporting. This building 2, I tried to use the geoprocessing tool and it failed for some reason. Building 3, it worked with the geoprocessing tool. So what's going to happen with this other tool is it's going to build a feature data set and put all the feature classes from the CAD data in it. So I'm just going to click OK to run it. It's going to create this data set and it's going to put all the CAD feature classes in it. What do I mean, all the CAD feature classes? I mean all of these. So let's just see it run. It takes a while. So while it runs, I'm going to tell you a little bit about this tool. This tool doesn't let us filter out any of our CAD data based on the layer we want it to be on. I am usually filtering out stuff before I put it into a CAD or into a geodatabase. So the main use of this tool is if you happen to have multiple CAD files that have the same, what we refer to as the schema or the same structure. For instance, let's look back at this CAD file. If you had a CAD file for every elementary school in Buncombe County, and they all had the same set of feature classes, they were all organized the same, what this CAD dataset to geodatabase tool really allows you to do is to bulk load many different CAD datasets into a geodatabase in a way that it allows you to manage many CAD datasets. And again, it allows you to do this kind of bulk load into your geodatabase. While that finishes up, the final tool that you're going to use that I'm not going to demonstrate is called CAD, import CAD annotation. So CAD files often have some annotation in them, and they can be very valuable so that you don't have to recreate all that text in your GIS. And so there's a tool for importing CAD annotation, and you'll search for it as well. Import CAD anno, and it doesn't find it unless I spell it all the way out. Their search tool is not as good as it could be. So import CAD annotation. This is the other tool that you're going to use. It converts a collection of CAD annotation features to geodatabase annotation. If you've worked with GIS much, or even if you haven't, it takes a lot of time to effectively and appropriately create labels and text and annotation in a GIS environment. Anything you can do to utilize annotation already created from some other format, in this case in CAD data, is very valuable. So you're going to use that tool as one of the last parts of your assignment. Now, the final thing is how do you submit this work to me? The submission requirements are that you submit to me a project geodatabase that includes a building feature class, a property boundary, annotation feature class, as well as the feature data set with all of the CAD feature classes. So you're going to, there it is, look at all that information that just came in from that tool. So the West Buncombe CAD feature data set I created has all of these feature classes. It put everything in there. So let's go look at our geodatabase here. Here's our geodatabase. I need to refresh it to show that, and it shows all that information in it. Now, again, I usually like to break things out more thematically before I do this, but essentially, you need to zip your geodatabase and provide it to me. Now, before you zip a geodatabase, you need to close ArcCatalog, make sure that everything's in it you need, and not more than you need. You need to close ArcMap, save that, and you zip files in in your File Explorer. Zipping a file is a operating system function. It's not really a GIS function. So we're going to zip this westbuncombe.gdb. Remember, this is your geodatabase. In File Explorer or Windows Explorer, it showed as a folder with a bunch of binary files in here. Don't mess around in this folder. Don't ever try to change a file in this folder, and don't ever save anything else to this folder. We right-click it, send to, compress folder, and now we've got our zip geodatabase to upload to Moodle for grading. Okay, if you have any questions, please contact me.